So I'm Stephen Brobst, Chief Technology Officer of Teradata, previously associated with MIT, Lawrence Livermore National Laboratory, and UC Berkeley. This talk is motivated by a high volume of industry hype in a particular category that I want to shed a different sort of light on. So we're going to talk about multi-temperature data management. And I think on this first slide, we all agree, right, that there's demand for lots of data. We've heard that all morning. And the demand for data exceeds the improvements in Moore's law. We also agree that we want more performance in accessing and doing useful things with this data. The market chatter that I find disturbing is that the answer seems to be, put all of the data in memory, and we're done with performance. And I would suggest that anybody who says, put all of the data in memory, does not understand XLDB or the economics of data access. So the typical logic goes, the cost of memory is dropping by roughly 30% every 18 months. That's a pretty well-known documented figure. I think we can all agree on that. And therefore, on a compounded basis, 30% reduction, that's very good, right? So eventually, the memory is cheap enough that we can store all our data and performance is done. I call this marketing math, because real math has two sides of any equation. So they gave us one side of the equation. What's the other side of the equation? How fast do your data grow? Okay? And any reasonably sophisticated organization analytically, I would argue that their data is growing by at least 50% every 12 months. The data is growing faster than memory is getting cheaper. So I'm going to suggest that this approach that I hear a lot about, probably the third most hyped concept in the industry after big data and cloud, is economically irrational. So let me give you some figures. This is real data taken from a large petabyte class data environment. And what you will notice is that more than 90% of the IOs are to less than 20% of the data. Okay? And this is fairly consistent across a large number of different kinds of workloads in different industries and so on. This is a relational database workload. And I would suggest that paying 100% memory price for all of this data makes no sense at all. Okay? And so the idea of multi-temperature data management is to simultaneously optimize two things, performance and price. In the end, that's what we care about. I think that we all want the best performance possible, but we want it at the lowest price possible. So the idea of multi-temperature data management is to recognize that a small percent of the total data is what I'll call hot data. And for that data, we want the lowest price per I/O. But for the vast majority of the data, in excess of 80% of the data, let's say, right? And I'm actually being fairly generous on these numbers here. It's actually probably more like less than 15% and more like above 90%, right? I want the lowest price per terabyte, right? I want those two things simultaneously. And so I'm going to suggest that it makes no sense to try and put all data in memory for this performance goal, because we're ignoring economics, and in XLDB, economics are important. So I believe that we need to start thinking differently about sort of how we manage the data. We need to think about a storage system which is hierarchical in its ability to sort of store and manage the data. Now, this is not at all a new concept, by the way, right? But I think that people are getting confused out there by all this hype. And so what I'm going to suggest is that we configure systems where we've got some combination, whatever the interesting storage technology is at the time. In memory, yes, it's important. SSD, important. Various form factors of electromechanical drives. Right? And what I want is more than 90% of the IOs to be done in memory and SSD, but I don't want to pay 90% of my data at that price. you would be willing to put your best DBA at work, send her away for 2 weeks and figure out what data goes in memory, what data is hot, what data is cold, place it all, manage it. If a human is involved, you're dead. At this scale, we need everything to be completely automatic. So that's the idea of multi-temperature data management. Thank you.